Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. CBSE very recently launched the new textbooks for class 6, 7, 8 and the books, if you go through the lines, they are amazing, full of activities, full of new things to learn, especially for the mathematics teachers. When we study all those in depth, you find mathematics is a beautiful subject having a lot of things which are still undiscovered, and you need to be a very good teacher, to teach those things to the students. One of the concepts which I took up in my previous video was this concept of supercells. I took up this concept and I have put that video also in the I button here so that you can watch that video also. And that was the first part of supercells videos where I took up a horizontal row grid like a 2 by 1 grid or a 3 by 1, 4 by 1, 5 by 1, likewise any number of cells in a single horizontal row. And I told you the concept. Now I am going to extend that concept to grids. That means to a grid of cells where we have more than one rows and more than one columns, like a 2 by 2, 3 by 3, 4 by 3, 5 by 3 kind of grids. And we will be learning the concept of supercells and how to frame the questions based on these supercells and solve all those questions comfortably. So if you are a school student, you need to watch the complete video. If you are a teacher, it is much more important for you to watch this video completely, understand them so that you can frame questions which can be asked to the students, in the exams or in the tests from the new NCERT book. So here I go, and before I start the supercells video, let me tell you about the short tricks in quantitative aptitude ebook which we have, which contains 24 different chapters and over 300 short tricks are there in this, so that you can excel in mathematics. You can develop 10 times faster speed of calculations. So if you are a school student studying in class 3, 4 onwards up to the placement level exams, this ebook is for you. What more, we are giving away the reasoning course also with the ebook of short tricks as a combo, and very nominal costing. And you can see the number of exams, the content of these ebooks target: Bank PO, SBI PO, CTET for the teachers, NTSC for the school students, or various Olympiads at school level, and then all sorts of placement exams. They become so easy when you have the basic aptitude, and this is what is the target of bringing out this amazing combo of short tricks and reasoning. You can send me a message on WhatsApp. This is the WhatsApp number 9896 369 963. That's mathematical, right? 9896 369 963. Send me a message. I'll tell you how to grab a copy of this amazing combo. Now let's understand the concept of the supercells in grids. So you can see so many grids drawn here. This is a 2 by 2 grid. This is a 2 by 3 grid. This is a 3 by 3 grid. This is a 3 by 4 grid. And this is a 5 by 4 grid. So what exactly are supercells? All these cells, that means these blocks, are called cells. Why do we call them supercells? Because when we fill this grid with numbers, maybe some particular numbers or any number, some of these cells or blocks will have the neighbors smaller than them. I'll give an example. See, suppose I have a number 92 here, and on the right side, on the left side, on top of it, and in the bottom, all these four neighbors of this cell, 1, 2, 3, 4. Remember, not the diagonal neighbors, okay? It is only the top neighbor, the bottom neighbor, the left and the right neighbor. If those neighbors, like for 92, this is the right neighbor. So this number, if it is smaller than 92, like 81, and the bottom neighbor here, this one, say 70, it is smaller, right? So both the right neighbor and the bottom neighbor are smaller than this, and therefore this 92 becomes a supercell. Okay, and now this can be a supercell or may not be a supercell. So if I write a number which is smaller than 70, say 61, now this one is not a supercell because its neighbor is higher than 81. This one is again, can it be a supercell now? Because the neighbors, the top neighbor is greater, so this is not a supercell. How about this? The top neighbor is greater, so this is also not a supercell. So in this grid, only one is a supercell. Only one of the cells, that is the one containing 92, is a supercell. Now this is the concept. Remember, when we are talking about neighbors, it is the top neighbor, the bottom, the right or the left neighbors, not the diagonal neighbors. Okay, let's understand this using a 3 by 2 grid. Now suppose in a 3 by 2 grid, we have, suppose I want this to be a supercell. So I'll write say 124 here, and now the neighbors, this neighbor has to be smaller than 124 if this is a supercell. So let's say 42, let's say 78, the bottom neighbor, and the left neighbor, let's say 101. See, all the three neighbors are smaller than 124, therefore this 124 actually is a supercell. Now if I want that this also should be a supercell, then its top neighbor and the left neighbor, they have to be smaller. So 42 and 78, so let's write a number greater than these two. Let's write 243. Now this becomes a supercell because the top neighbor and the left neighbor, it has only two neighbors, both are smaller than this. Now if I want this also to be a supercell, I can put a number which is greater than 101 and 78. If it is less than these two or any one of them, like suppose 92, then 101 is greater than 92, so this does not become a supercell. So in this grid we have only two supercells and rest four are normal cells. So what do you think, how many supercells are possible? Is it possible to get all 6 supercells? Not at all, right? Because if one number is greater than the other one has to be smaller. So you cannot have equal number of supercells as contained in the grid itself. Let's decode it here. Now suppose I want this to be a supercell, and then I want, let's take one more number, say here this to be supercell, and I want another corner, say this to be a supercell. So I can put numbers here which are in which these three blocks, they become supercells. How about using 96 here, 105 here, and 86 here? Now can I fill the remaining blocks so that only these three are supercells? I can. This number has to be greater than these two, right? So let's write 46 here and 58 here. So this becomes a supercell now. How about this? This is smaller than 105, so this has to be smaller than 105 and smaller than 86 also. So let's write a 71 here. So this becomes a supercell now. How about this? 71 is smaller, so let's write 28 here. So this also becomes a supercell. Now I don't want this to be a supercell. This has 4 neighbors, 1, 2, 3, 4. If I write 100 here, it will become a supercell because it is greater than 58, 46, 71, 28. But I don't want to be it to be a supercell. So one of them or two of them or three of them or four of them, they have to be greater than this number. So let's say this number is 62. Now how about 62? See, 71 is greater than 62, so this is not a supercell. Now I don't want this to be a supercell. So 58, let's make it greater. So 41, this 58 is greater than 41, so this is also not a supercell. See, so if the supercell are marked in the figure, then you can actually fill the grid with numbers so that they are the actual supercells. So how many supercells do you think can this have? Can this have 7 supercells? We will decode in a minute. So likewise, we can fill this grid with numbers so that we can have some supercells. Remember the rule. Here we have 1, 2, 3, 4. 4 blocks. So if this number of blocks is even, then just take half of this. 4, the half is 2. So this grid can have a maximum of 2 supercells. Likewise, 1, 2, 3, 4, 5, 6. It has 6 cells. Now 6 again is even. Half of 6 is 3. So maximum number of supercells this grid can have is 3. Now how about the odd ones? 1, 2, 3, 4, 5, 6, 7, 8, 9. Now 9 is an odd number. So when I take half of 9, it will be 4.5. I can't have 4.5 supercells, either 4 or 5. Take the larger number. That is, the maximum number of supercells here is 5. Why? Because 9 is odd, so I will take the next number 10 and take the half, n plus 1 by 2 in case of odd numbers. So 9 plus 1 by 2 is 10 by 2, that is 5. So 5 maximum supercells can be there in this one. How many supercells are possible here? The maximum number. I am talking about the maximum number, not the minimum. Minimum can be 1 also. Single supercell out of all these blocks can be the one supercell. Now let's see here. How many cells are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 is even, right? So this can have a maximum of 6 supercells. Here we can have a maximum of 6. Now let's see how. If this is a supercell, this cannot be a supercell. This can be, this cannot be. This cannot be because this is a supercell, its neighbor cannot be a supercell, right? This can be, this cannot be, this can be. And then likewise here, this can be, this cannot be, and this can be. So a maximum of 6 supercells here. Likewise, if you see this grid 4, 4, 4, 4, 4, 20, right? So 20 means even number of blocks and half of 20 is 10. So it can have a maximum of 10 supercells. So if you start with this one, 1, 2, just go alternate. 3, 4, 5, 6, 7, 8, 9, 10. It can have only these 10 supercells, or the other way around. 1, 2, 3, 4, the unticked ones, they can also be the supercell. So a maximum of 10 supercells are possible in this grid. Now what will the questions be like? If you see the NCERT book, the questions are like this. Some of the blocks in a given grid, they will be highlighted. Like see, we have some highlighted or the colored blocks here. Now they are the ones which are supercells. The highlighted cells are supercells. Now we want to fill this grid with 4-digit numbers. Now this is a question. 4-digit numbers. All of them have to be 4-digit numbers made from the digits 4, 6, 1, or maybe you can take one more digit because it's a 4-digit number and we are not allowing the repetition. Let's take a 3 also. Right? Now I want to use all these digits to create 4-digit numbers, and we don't want to repeat the digits. If repetition is allowed, then these 3 digits are also possible. Now here also, if we say without repetition, then 4-digit number we need 4 digits, so we can add one more, say 1, 1, 5, 7, 9, or then we can make 4-digit numbers. Now using 1, 3, 4, 6, we need to make 4-digit numbers such that this is only this block is a supercell. So I want to make a bigger number here. So let's put 6, 4, 1, 3 here. Now that's a big number, right? Now its neighbor, these two neighbors, they have to be smaller than 6, 4, 1, 3, and all the digits should be the same but in reverse or different order. Like if I write 3, 4, 6, 1 here, and if I write 4, 3, 1, 6 here, so this becomes a supercell now. Now I don't want even this to be a supercell. So I can start with a 1, 1, 6, 4, 3. How about this number? Now you can check, because this is a supercell greater than these two. Now these 3 are not supercells. and that actually answers our question. Now likewise, if I want this and this to be a supercell and these are non-supercells, then the student will be required to frame numbers out of 1, 3, 4, 6 by rotating the digits and then putting some numbers here, 4-digit numbers, so that only these two are supercells. Now for that, let's make big numbers here. Now suppose I have a 4, 6, 1, 3 here and a 6, 3, 4, 1 or 1, 4 here. These two, if they have to be supercells, they have to be greater than the neighbors. So we can put a smaller number here, 3, 6, 4, 1, and another maybe 1 starting with 1 or another number starting with 3, maybe 1, 6, 4, 3 here. And now you can check, this is a supercell because it is greater than these two. This is a supercell because it is greater than these two. Likewise, if we have a bigger grid, like here we had a 2 by 2 grid with indicated supercells, here we have a 2 by 3 grid, 2 rows, 3 columns. Now in the first question, he says these three have to be supercells and the numbers which we have to use digits are 1, 5, 7, 9 without repetition. That means you can't write 5, 5, 7, 7 like that in a single number. If repetition is allowed, even 3 digits are enough. So I added one more digit because we have written without repetition. Okay. So 4 digits. Now let's consider that this is a supercell. So I will write maybe, see, the smallest numbers have to be non-supercells, right? So starting with 1, 1, 5, 7, 9 is the smallest number. So this will never be a supercell now. And likewise, you can rotate the digits and write 1, 7, 5, 9 here or 1, 5, 9, 7 here. Now all these numbers are not going to be supercells because I started my number with 1 only. But if this has to be a supercell, it has to be greater than these two. So I will start with a 5. 5, 1, 7, 9. Now this is a supercell obviously. This has to be a supercell. So again I will start with a 5. 5, 9, 7, 1. Now this becomes a supercell because it is greater than all three. And finally this has to be a supercell. So I will start with a 9 maybe. 9, 1, 5, 7. Now you can check all these three are supercells and remaining three are not supercells. In this similar manner, we have another question where the supercells are different than the previous matrix. So we need smaller numbers here. 1, 5, 7, 9, 1, 7, 5, 9. Maybe we can write 1, 9, 5, 7, and then we can write another one say starting with a 5, 5, 1, 7, 9. Right? Now I want these two to be supercells. So because I have not written any number starting with 7, the three neighbors here, if I start the number with 7, these three will be smaller and so this will become a supercell. So 7, 1, 5, 9, that is a supercell now. And these two are starting with 5 and 1, so I can start with a 7 or a 9, 9, 5, 7, 1. So this also becomes a supercell. Easy, right? Now similar things you can do with larger matrices. Here there are again 4-digit numbers to be formed and we have 3, 5, 6, 8 to be used without repetition. So look at the supercells 1, 2, 3. So we want to frame numbers from 3, 5, 6, 8, put the larger ones here and smaller ones here so that only these three becomes the supercells. So I will give this question as a DIY for you so that you can also practice. I will do more complicated ones here in this one. Try to get these three as supercells and these all numbers formed from the digits 3, 5, 6, 8. All of them have to be 4-digit numbers and they should not be supercells. Try this. In the meanwhile, let's try this first. This is a 3-row, 4-column matrix, 3 by 4 grid, in which the digits which are to be used are 1, 6, 7, 9 and they are all 4-digit numbers. So let's take care of the non-supercells first because those are the ones which have to be smaller ones. So I will start with the smallest number 1, 6, 7, 9. Let's put it anywhere, say here 1, 6, 7, 9 because that is the smallest, it will never be a supercell. Using 1, I can frame more numbers 1, 6, 7, 9, 1, 7, 6, 9, that's another number. How about 1, 9, 6, 7? How about 1, 1976. See, all these numbers are beginning with 1 only. So they are the smaller numbers. I can write more numbers also, but see, starting with 17 I wrote 1769. So I can write 1796 also. That is another combination. Starting with 16 I wrote 1679. I can write 1697 also. See, all these are different numbers and they are all beginning with 1 only. But I need 2 more. So let's start with a 6. How about a 6179 or a 6791? See, all these numbers are smaller. Now I want the supercells. So for supercells, I will write the larger numbers. The numbers beginning with 7 and 9, they will always be greater than all the numbers which I have written. So you can check the first one here. Starting with a 7. So if I write 7196, this will become a supercell because the top number and the right number, both of them are smaller. How about this one? I need a number which is greater than this, this and this, the 3 neighbors. So this number, let's start with 7 again. How about 7169? This becomes a supercell now, and there is no repetition of numbers. The numbers are all different. How about this one? So I have to start with a 7 again, or maybe start with a 9. So I can start with a 9 here. So if I write 9167, does this become a supercell? Because all the 4 neighbors are smaller. And finally this one has to be a supercell. So beginning with 9 again, 9761. Now does this become a supercell? Now you can check. All the non-shaded ones are non-supercells and all the shaded ones become supercells. Right? Now if you try to analyze this, there might be some cells which have by default become supercells. So I want you to identify and check whether all these non-shaded ones, which maybe I'm putting a underline those here, all the non-shaded ones, are these non-supercells, or is there any repetition which we have done? If we have done some repetition, then we need to change the number. If the non-highlighted ones become supercell, again then we have to change the number. So I want you to try as a DIY exercise that whether we have committed any error in this or not, and then we can try to do some more questions like this. Now if you see this question, here we have taken 4 row 4 column, that is 4 by 4 grid, and we want to fill it with 4 digit numbers using 2, 3, 5, 6. The highlighted ones are to be the supercells. So I am filling these with some of the numbers. Like if I write 6532 here, see I am writing a big number because I want this to be bigger than the neighbors. So I will write a maybe 5632 here, and then this one again beginning with 66253 here, and then let's take a smaller number also, 3652 here, and another supercell, so beginning with 5, maybe 5623. So you just need to take care that you are not repeating the 4 digit number. Okay, so I have written some numbers here. Now this number has to be smaller, so maybe a 3526. Now does anyone become supercell here? Not yet. Let's try this, a smaller number, 2365 here. Still it doesn't make anything supercell. 2653 here. Now this becomes a supercell because it is greater than these two. Now to make this as a supercell, I need a number here, suppose 3625. So now this becomes a supercell because the neighbors are smaller. When will this become a supercell? Because I have a smaller numbers all around. I need one more here, maybe a 5263. Now this becomes a supercell. How about this? 1, 2, 3 and 4, these two, right? So these two have to be smaller than 3652 also. So maybe a 3562 and here 2365, and now you can check this becomes a supercell, and this has automatically become a supercell because all 4 numbers are smaller, and I need smaller numbers here. 3, 2, 6, 5. It will never be a supercell because this is greater. This one may be a 3, 2, 5, 6. But this is likely to become a supercell if this number becomes smaller than this. So I need a smaller number here, maybe a 2, 3, 5, 6. And now this is not a supercell. This is also not a supercell because this is greater. And for this not to be a supercell, it has to be smaller than 5, 2, 6, 3. So maybe a 5, 2, 3, 6. And now you can check the grid. Only the highlighted ones will be the supercells and non-highlighted ones will be non-supercells. Friends, this is not easy actually. You know, when you do trial and error, when you try to put in the numbers, the students are going to, do some permutations and combinations, and lot of repetitions will take place. Even when I was framing this video, I committed lot of errors. So it is not an easy exercise, and that is why the chapter's name is number play. The student has to play with all these digits, form 4-digit numbers which are greater or smaller than, so many things are there, so many parameters are to be taken care of. Let's see one more big question here. Now we have 5 digits, 4, 1, 0, 8, 9, and it involves 0 also. So when we make 4-digit numbers, you can't make 4-digit numbers starting with 0. It can't be 0, 4, 1, 8. Then it will become a 3-digit number. So that is another parameter which is added to this question. So I have done one solution of this already so that we can save time. And the highlighted ones, 1, 2, 3, 4, 5, 6, these are all supercells, and rest they are non-supercells. So for this one, the supercells I have made are 8, 4, 0, 1, 9 here. See, why am I starting with 8 in the supercell? Because that will be the larger number. Starting with 8 or starting with 9 will be the bigger numbers. So I am taking 5-digit numbers. To complicate it further, let's say 5-digit numbers, no problem. You can take 4-digit numbers also, 3-digit numbers also. So I am doing 5-digit numbers here. Okay, just to complicate it and show you that even 5-digit numbers will also work in the grid, right? Next up we have 81094 here. This is again a 5-digit number. Be careful not to start with a 0, okay? And then we have number 94081 here, which we can put in this cell. 89401 here. See, all numbers beginning with 8 and 9, and you understand the purpose now. Okay, let's take a smaller number also, and I'll show you how this becomes a supercell. 49801, and then at the corner we have 98410. Right. So these are the supercells. Now I want to put 5-digit numbers in the remaining ones so that they are not supercells. Okay. So let's try one by one. In the corner here, 89401. So if I write 14098, this is smaller, and another number here, it can be greater or smaller because one number is smaller, so one can be greater also. Okay. So 84901. Now this number, does it become a supercell? This number is a supercell because these two numbers are smaller than this. Now let's make which one? Maybe this one, 94081 is supercell by filling in these two numbers, and for that 80149 is the smaller number here, and corresponding to that 48091. So this becomes a supercell now. You can check all the 4 neighbors. And finally now here 49801. This is smaller, this is smaller. So I need a number here, 10849. And now you can check, this becomes a supercell. And this number is smaller than this. So I can put a number here to make this as a supercell. And for that 98401 is what I am using. Now this has also become a supercell. For this one, we need 2 smaller numbers here, first and third. So this is 48091, and for the third one I have used 19048. So you can see this has become a supercell now. For this one, 3 are already there. I need a number here which is 18904. See, no repetition is being done and all numbers are different numbers. So this becomes a supercell. and now the remaining numbers I can fill 40819. You will check this is not a supercell, this is not a supercell, and all these are not supercells. Likewise here 90481. Now be careful here, 90481 might become a supercell. Two neighbors are smaller. If this is also smaller, then it will be a supercell. So 94801, why did I take that? Because this is not a supercell now. This can become a supercell if this number is exceeding this. So I need a greater number there, 98 and maybe a 104 here. And finally we have one more number. This has to be, if it becomes a supercell, all these numbers will be smaller. So I need a number which is maybe smaller than any four of them, right? So for that 41098 is what we are taking. And now you can check, does it satisfy the conditions given in the question? 5-digit numbers using these, 0 cannot be the first place, all these non-highlighted ones are non-supercells, highlighted ones are supercells, the top, bottom, left, right neighbors have to be smaller, so many parameters. And being a teacher also, if you start doing this, you will realize there are so many things to think about, and it's a mind-boggling puzzle. So friends, if you like this video, do share it with all your friends so that they start getting used to these number play activities. And this is a class 6th activity, and it's not that easy. So friends, if you like this video, do share it with all your friends who are currently in class 6 or going in class 6. They can start playing with these numbers. Even in the absence of the teacher, at home also they can do this activity. Do like the video, and after liking, you will find an option of hyping the video. So you can give some points to the video to hype the video, so that it becomes accessible to many people who are looking for such kind of videos. So friends, thanks for watching this video, and all the best for your practice of supercells.